Hello students, welcome to Aptdemy's live platform. We'll be considering a problem on ellipse. So this problem we are going to consider. See the statement of the problem. If tangents are drawn to the ellipse x square plus 2y square equal to 2, then the locus of the midpoint of the intercept made by the tangents between the coordinate axes is. There are four options. Which one is correct? That we have to find out. So, what is the equation of the ellipse? X square plus 2y square is equal to 1. So, I can write x square by 1 plus y square. It is 2, sorry, not 1. It is 2. This is 2. So, x square by 2. So, let me clear it once again. So it is x square by 2 plus y square by 1 is equal to 1. Therefore, the A, the semi-major axis of the ellipse is √2 and semi-minor axis is 1. Okay. Now, if tangents are drawn to the ellipse, then the locus of the midpoints of the intercept made by the tangents between the coordinate axes is which one? So, just let us consider the ellipse. So, this is the ellipse. This is x-axis, this is y-axis, this is x-dash. Now, if a tangent is drawn, then the locus of the, if tangents are drawn to the ellipse, then the locus of the midpoint of the intercept made between the made by the tangents between the coordinate axes. So this is the intercept made by the tangent between the coordinate axes. Then what is the midpoint of this intercept? Locus of the midpoint of the intercept, that you have to find out. So another tangent may be here at this point. So the intercept between the coordinate axis is this much, this length AB. And what is the midpoint of AB? So you keep on drawing all tangents of the ellipse and pick up the midpoints. And if you connect all these midpoints, then it will take a shape. And what is the equation of that shape? What is the equation of that locus? That you have to find out. Now, to solve this problem, let us use the parametric coordinates of points on the ellipse. So if this is the given ellipse, then any point P on the ellipse can be written as P coordinate as √2 cos theta sin theta. But theta is an angle expressed in radian or degree. So this point, whatever be the value of theta, this point always satisfies this equation. This is the parametric form of the coordinates on the ellipse. So √2 cos theta, if you plug in x equal to √2 cos theta, so it becomes 2 cos square theta by 2, that is cos square theta plus sin square theta. It is always satisfied. The left hand side is equal to right hand side. So √2 cos theta sin theta is an arbitrary point on the ellipse. Okay. Now let us compute the equation of the tangent of this tangent of the ellipse passing through this point P. So for that, what we do? Let us from this equation let us calculate dy dx. So for that, just differentiate with respect to x. So it is 2x plus 2y dy dx is equal to 0. So dy dx is minus x by y. So dy dx, value of dy dx at the point P is how much? X is minus x by y. So I can write root 2 cos theta divided by sin theta. So it is how much? Minus root 2 cot theta. Okay. So if I draw a tangent at the point P whose coordinate is root 2 cos theta sin theta, then the gradient of the tangent drawn at the point P will be minus root 2 cot theta. I hope it is clear up to this point. It is always advantageous to use the parametric form of the coordinates on the ellipse. Otherwise, if you take a point x1, y1 on the ellipse, then you have to satisfy this condition x1 square plus 2y1 square equal to 2. But if you take parametric form, automatically it satisfies the equation of the ellipse. So dy dx equal to minus root 2 cos theta is the gradient of the tangent at the point P. So what is the equation of the tangent T dash PT? At the point P, what is the equation of the tangent? It is nothing but y minus y1, which is sin theta, equal to minus root 2 cot theta x minus root 2 cos theta. So this is the equation of the tangent. Tangent means its gradient is minus root 2 cos theta we have just determined, and it is passing through the point root 2 cos theta sin theta. So equation of the line passing through this point having gradient this much is this much. As simple as that. So if I simplify this, it is actually y plus root 2 cot theta x multiplied by root 2 cot theta is equal to how much? Minus root 2 cot theta into minus root 2 cos theta. So it is 2 cos square theta by sin theta. I can write minus minus plus 2 cos square theta by sin theta, and this sin theta goes in the right hand side, so it is like this. So it is what? Okay, so let me once again check this thing. 2x plus 2y divided x equal to 0. So dy dx is minus x by y. So dy dx is actually root 2 cos theta by sin theta. It is root 2 cot theta. So y minus y1 is equal to root 2 cot theta x minus x1. So y plus x root 2 cot theta is equal to 2 cos square theta by sin theta plus sin theta. Okay, so it is sin theta 2 cos square theta plus sin square theta. Okay. Okay. So there is some mistake somewhere. This thing. This is actually dy dx is x by 2y. See, it is 2x plus 2y dy dx. So dy dx is actually this is 4y. Come, some mistake is there. Just let us do it. This is 2x plus 4y dy dx is equal to 0. So it is dy dx is actually minus x by 2y. Okay. So it is x is root 2 cos theta and 2y is 2 sin theta. So it is actually, there is a calculation mistake. So it is cos theta divided by root 2 sin theta. So it is cot theta divided by root 2. Okay, so the equation of the straight line becomes how much? So there is a negative sign over there. So minus 1 by root 2 cot theta. So dy dx is x by minus 2y. So it is minus cot theta by root 2. So how much it is? If we rewrite this equation, so y plus cot theta by root 2 x is equal to cot theta cos theta plus sin theta. So it is how much? So it is cos square theta by sin theta plus sin theta. So it is 1 by sin theta only, because cos square theta plus sin square theta, it is 1 by sin theta. So the equation of the tangent becomes y plus cot theta by root 2x is equal to 1 by sin theta. So I can write it is cot theta sin theta divided by root 2x plus sin theta y is equal to 1. So I can write from there. It is actually x cos theta into sin theta is cos theta. So x cos theta, so it is x cos theta by root 2 plus y sin theta equal to 1. Then I can also write this is x by root 2 divided by cos theta plus y divided by 1 by sin theta is equal to 1. So if it intersects x-axis and y-axis at point A and B, then coordinate of A is how much? It's very simple. It is 1, 0 by 0, 1 by sin theta. And here the coordinate of B will be root 2 by cos theta, 0. So if the x-axis intersect, if I call it alpha, coordinate of B, if I call it alpha 0, then alpha is how much? Alpha is root 2 by cos theta. And if A's coordinate is 0 beta, then beta is how much? Beta is 1 by sin theta. Okay, so let me remove all these things at this point. So alpha 0 and 0 beta are the point of intersection of tangent with x and y axis. So what is the midpoint of alpha beta? So all midpoint of AB midpoint of AB is HK, say, then H is how much? H is alpha by 0, alpha by 2, alpha by 2, alpha plus 0 divided by 2, and K is 0 plus beta divided by 2. So H is how much? Alpha plus 0 by 2, alpha is this much, root 2 by cos theta. So it is root 2 by cos theta into half. So it is 1 by root 2 cos theta. I think steps are correct. And K is how much? It is beta by 2. Beta is this much. So it is 1 by 2 sin theta. Okay. Now HK's locus of HK, I am interested in. So I have expression for H. H is 1 by root 2 cos theta and K is 1 by 2 sin theta. So if I can eliminate theta between these two equations, then I can get the locus of this. So for that, what I do, cos theta, I write 1 by root 2h. And sin theta, I write half, 1 by 2k. Okay, and cos square theta plus sin square theta equal to 1. So I can write 1 by 2h square plus 1 by 4k square is equal to 1. Okay, so this is the relation between hk, and this relation is always satisfied. So the equation of the locus will be, just replace h by x and k by y. So it is 1 by, just let me remove this thing. So equation of the locus is 1 by 2x square plus 1 by 4y square is equal to 1. So 1 by 2x square plus 1 by 4y square equal to 1. That is actually this option. 1 by 2x square plus 1 by 4y square equal to 1. So A is the correct answer. So this is the correct answer. This is the equation of the locus of midpoint of the intercept made by the tangent between the coordinate axis. So this is the required equation. One thing, so when we are interested to find the equation of the tangent to this ellipse at any arbitrary point, root 2 cos theta sin theta. So what we did, we started with differentiating this equation. So 2x plus 4y dy dx equal to 0, and then dy dx we computed as minus 2x by 4y. So it is minus x by 2y, that is x is root 2 cos theta minus root 2 cos theta by 2 sin theta, which is actually minus cot theta by root 2. That was the gradient of the tangent at the point P. And from that, we found the equation of the tangent like this. Okay. But simply, you can write without doing all such calculation. When the given equation is x square plus 2y square equal to 1, then the equation of the tangent at the point x1, y1 of a ellipse can be readily written as ax x1 plus 2. Instead of, in place of x square you write x1, in place of y square you write y1. So y1 equal to 1. And here, what is the x and x1? So it is basically, just let me remove from here. So this equation, how does it look like? So x1 is how much? X1 is actually root 2 cos theta, because we told that any point on this ellipse is actually root 2 cos theta sin theta. At this point, this is the coordinate of P we started with. So at this point, just what is the equation of the tangent? We can readily write like this, where x1 is root 2 cos theta and y1 is sin theta. So it is x into root 2 cos theta plus here 2y into sin theta. Okay, is equal to 1. So I can readily write the equation of the tangent like this. So what is happening? X into root 2 cos theta equal to plus 2y sin theta equal to 1. Okay, so this is actually x1 x square plus 2y square equal to 1. From that you can find out the equation of the tangent. So equation of the tangent, we wrote it is gradient of the tangent is minus cot theta by root 3. So equation of the tangent is y minus sin theta, because you see it is given equation is x square plus 2y square. So x square by 2 plus y square by 1 equal to 1. So our here actually it is wrong. Equation, our given equation is x square plus 2y square equal to 2. So it is 2. So our equation here it is 2. X root 2 cos theta plus 2y sin theta equal to 2. So I can write the equation of the tangent as x cos theta divided by root 2 plus 2y sin theta, or if I divide by 2 simply, so I can write it is x root 2 cos theta by 2 plus y sin theta equal to 1. So it is, I can also write x cos theta by root 2 plus y sin theta equal to 1, or I can write x divided by root 2y cos theta plus y divided by 1 by sin theta equal to 1. So in this way also we can write the equation of the tangent, which is same as this: x by root 2 cos theta plus y by 1 by sin theta equal to 1. So what you do, whatever given equation is there, so our given equation is x square plus 2y square equal to 2, not 1, it is 2 this side. So from this, if you want to find the equation of the tangent at the point x1, y1, you just write in place of x, you write x, x1, and in place of x square, you write x, x1, in place of y square, you write y, y1. So 2y, y1 is equal to 2 in the given equation. And x2, x1 is equal to root 2 cos theta, substitute, and y1 is equal to sin theta, and readily you can write the equation of the tangent like this. Okay, so you need not differentiate the equation, you need not determine dividends, you need not determine the equation of the straight line. So readily you can write like this and you can solve the problem quickly. Okay, this is a small tip for handling such type of problems. Okay, thank you very much. Actually, in case of any equation, if there is a 2x or 2y type of term, by determining the tangent, you replace 2x by x plus x1 and 2y by y plus y1. And if there is a x square type term, you replace x square by x1 and y square by y1. And readily you can write down the equation of the tangent. So if there is the equation of circle, x square plus y square plus 2gx plus 2fy plus c equal to 0. So in place of x square, if you are interested to find the equation of the tangent to the circle at the point x1, y1, in place of x square you write x1, in place of y square you write y1, and in 2gx means g times 2x. 2x you replace by x plus x1, where there is a 2fy, then f into 2y replaced by y plus y1, and then simplify. And while simplifying, you must remember that x1, y1 satisfies the equation of the circle. So x1 square plus y1 square plus 2gx1 plus 2f y1 plus c is equal to 0. So wherever x1 square plus y1 square terms are there in the equation of the tangent, you replace that from that relation. That means x1 square plus y1 square plus 2gx1 plus 2fy1 plus c equal to 0. So readily you can find out the equation of the tangent without differentiating the given equation. Okay. So with this you can readily quickly solve such type of problems in competitive exams. Thank you. Thank you for listening.